Hey there, science fans. Let's talk about the moon, that big, beautiful circle in our night sky. It's not just there to look pretty, you know. The moon is super important to our planet Earth. Think of it as Earth's best buddy in the vastness of space. It's been hanging out with us for billions of years, and it does a lot of heavy lifting to make Earth a great place to live. It's a cosmic neighbor with some serious influence, and its presence has shaped our world in incredible ways. One of the moon's biggest jobs? Tides. Yes, those waves at the beach that go in and out, sometimes gently, sometimes with great power. The moon's gravity pulls on Earth's oceans, creating a sort of bulge. This pull creates a bulge of water on the side of Earth facing the moon, and another on the opposite side due to inertia. As Earth spins on its axis, we pass through these bulges of water. That's high tide. Then when we're not in a bulge, it's low tide. This constant movement is vital for coastal critters and mixes ocean nutrients effectively. Pretty powerful for a rocky pal, eh? And get this, the moon helps keep Earth from wobbling too much on its axis. Our planet is tilted, you see, at an angle of about 23.5 degrees relative to our orbit around the sun. This tilt is what gives us our amazing seasons. Spring, summer, autumn, winter. You can thank the moon's steadying gravitational influence for this regular pattern. Without the moon acting as a sort of gyroscope, Earth might tip over much more drastically over long periods. Imagine the crazy, unpredictable climate changes that would cause. The moon acts like a gravitational anchor. Billions of years ago, Earth spun much, much faster than it does today. A day might have been only a few hours long. Can you imagine trying to fit school, sleep, and science experiments into such a short time? The moon's gravity has acted like a gentle brake on Earth's rotation over eons. This interaction has slowly made our days longer, leading to the familiar 24-hour day we have now. This fascinating process, born from tidal forces, is still happening, very, very slowly. The moon is a key player in Earth's daily rhythm and its long-term geological history. Science is all around us. Now imagine something truly wild happens, something straight out of a science fiction movie. Let's say the moon, our faithful companion, starts moving closer to Earth. This isn't something that would happen naturally under current physics, it's actually slowly drifting away. But for our thought experiment, let's imagine a rogue planetoid bumped it, or some unknown cosmic force is pulling it towards us. At first, we might just notice the moon looks a bit bigger and brighter in the night sky. Amateur astronomers with their telescopes would certainly be buzzing with excitement and confusion. But scientists? They'd be sounding the global alarms because this is serious stuff, folks. As the moon creeps nearer and nearer, its gravitational pull on Earth gets way, way stronger. Remember those ocean tides we talked about? They'd become enormous, truly colossal. We're talking super tides, perhaps hundreds of feet or even meters high. Coastal cities like New York, Miami, Shanghai, or Tokyo would be completely swamped, disappearing under the waves. Imagine massive walls of water surging far inland, not just once, but multiple times a day, with every high tide. Beaches would vanish, and entire coastlines would be dynamically and catastrophically reshaped. Living anywhere near the ocean would become utterly impossible. The weather all over the planet would go absolutely bonkers. The moon's increased gravitational force wouldn't just tug on the water, it would pull significantly on our atmosphere too. This could stir up colossal storms, far bigger and more powerful than any hurricane or typhoon we've ever witnessed or recorded. We might see constant violent winds sweeping across the entire globe, making air travel a distant memory. Rainfall patterns would shift dramatically and erratically, causing extreme continent-drenching floods in some places, and terrible landscape-cracking droughts in others. Our planet's climate system would be thrown into complete chaos. And what about all the animals and plants? They'd be in a world of serious trouble. Marine life that depends on regular, predictable tides for feeding, breeding, and shelter would be completely disrupted, if not wiped out. Think of crabs, sea turtles, and countless species of fish in coastal areas and estuaries. Their homes and crucial breeding grounds would be utterly destroyed by the relentless giant tides. Land animals would struggle immensely with the extreme weather, the violent geological changes, and their habitats changing faster than they could ever adapt. Birds that navigate using the moon might get totally lost. Entire ecosystems would undoubtedly collapse. Okay, science explorers, things are getting really intense now in our scenario. The moon is getting dangerously close to Earth, so close in fact that it enters what scientists call the Roche limit. This is a critical distance. Inside this limit, Earth's gravity pulling on the near side of the moon is significantly stronger than its pull on the far side, and stronger than the moon's own gravity holding itself together. So what happens? The moon starts to break apart. Chunks of moon rock, big and small, would begin to fracture off its surface. It would look as if our familiar moon is crumbling right before our eyes. These broken pieces of the moon wouldn't just float away peacefully into space. Nope. Earth's immense gravity would greedily pull them in. We'd see a constant, terrifying barrage of meteors, but these aren't the tiny shooting stars that make you go ooh and ah. We're talking massive boulders, even mountain-sized chunks of rock crashing down onto Earth's surface. The sky would be filled with brilliant, deadly fireballs day and night, making it look like a cosmic fireworks show gone horribly wrong. These impacts would cause huge explosions, trigger powerful earthquakes, and start continent-spanning wildfires. Earth itself, the very ground beneath our feet, would feel the immense strain of the approaching lunar mass. The moon's gravity, now incredibly powerful at this close range, would cause earth tides or land tides of an extreme nature. The solid ground would bulge up and down, just like ocean tides, but with rock. This would lead to catastrophic earthquakes, far beyond anything ever recorded on the Richter scale, happening constantly all over the globe. Volcanoes, dormant for centuries, would awaken and erupt violently, spewing choking ash, poisonous dust, and molten lava into the atmosphere, further darkening the skies. For any humans still around at this point, it would be an unimaginable nightmare, a fight for sheer survival. Cities and all infrastructure would be ancient history, long obliterated by the colossal tides, the unending earthquakes, or the relentless meteor impacts. The air would be thick and unbreathable, choked with volcanic ash and dust from meteor strikes, requiring special breathing apparatus if any were left. Finding clean water or any source of food would be almost impossible. The constant threat of falling debris and the ground shaking violently would make survival a minute-by-minute desperate struggle against overwhelming odds. This is it, folks. The final devastating act in this cosmic drama. The largest remaining pieces of the shattered moon, or perhaps its dense core if it has one, can't escape Earth's powerful gravitational pull any longer. They come crashing down onto our planet. The impact or series of impacts would be beyond anything we can truly, fully imagine. Think of the energy of billions of the most powerful nuclear bombs ever created exploding all at once, in one spot. The energy released would be absolutely staggering, instantly vaporizing rock, water, and anything within thousands of kilometers. A colossal impact crater, possibly spanning entire continents, would be gouged into Earth's surface. The immediate aftermath of such a big smash, a global inferno of unimaginable proportions. The impact would blast trillions of tons of superheated rock, dust, and vaporized moon and Earth bits high into the atmosphere and even into orbit. This dense cloud of debris would quickly encircle the entire planet, blocking out the sun's vital light for months, maybe even for years or decades. After an initial searing heat wave from the impact energy that would boil oceans and melt rock, Earth would plunge into a deep, dark impact winter. Temperatures would plummet globally to far below freezing. The surface would first be sterilized by extreme heat, then frozen in darkness. What would be left of our beautiful blue Earth? It would likely survive as a planetary body, but it would be a molten, scarred, and profoundly changed world, almost unrecognizable. A huge portion of Earth's crust and its upper mantle might melt completely, turning the surface into a sea of lava. The atmosphere would be a toxic, dust-filled, greenhouse gas-laden mess for a very, very long time. Over millions of years, if Earth is lucky, it would slowly cool down and solidify again. It might even form a new smaller moon, or several moons, from the orbiting impact debris, or perhaps a spectacular ring system like Saturn's. Could any life, as we know it, make it through such an apocalyptic event? It's highly, highly unlikely for humans or any large animals and plants on the surface or in the shallow oceans. The conditions would simply be too extreme. Perhaps some very tough microbes like extremophile bacteria living deep within Earth's crust or near hydrothermal vents in the deepest parts of the ocean might somehow cling to existence. But for complex life, it would be an extinction event to end all extinction events. If life were to ever return, it would take hundreds of millions of years to re-evolve, starting from the simplest, most resilient survivors. Earth would be reset.